Hello, my wonderful viewers. I want us to look at this question together. This is a chemistry question that is actually peculiar to students who want to write higher tier AQA. So I'm talking to the AQA students now. For those of you who are in the UK, you know what I'm talking about. For your AQA, you are either going to write foundation tier or higher tier. So this is basically for the higher tier student. You'll be faced with this actually. Look at this question. My intention is to use this one stone to kill all the birds around here. How is that possible? I'm going to break it down, don't worry. Let's read the question together. They said a typical small cylinder of butane. This is butane. This is the formula for butane. A typical cylinder of butane used for camping contains 5 kg. This is the information we know. So we know two things, that it is butane, the compound is butane, and we have 5 kg of butane. They want us to do something with this information. They said that we should write a balanced symbol equation for the complete combustion of butane. Interesting. A lot of us will see this question and we will not even, where is this question coming from? For those of us who are going to write WAEC and JAM, I'm going to touch where this will concern us. What is this? What are they talking about? There are actually two things that we will need. This is the A part of the question. Write a balanced symbol equation for the complete combustion of butane. 2, if all the gas was burnt in plentiful supply of air, what would be the maximum mass of carbon dioxide released into the atmosphere? So this one, we're going to go back to quantitative chemistry, quantity. We're going to look at this. Then here, we're going to dangle around hydrocarbons. So I will not go into answering these questions right away. What am I going to do? I'm going to prepare us. I'm going to use this to explain something in chemistry. And after that, I will come back to this question. I'll answer A and B and leave us with a question in this similitude for us to try, for those of us who are following. Okay, so we know already that this is butane. Butane. Please take note. Butane. So I already know that because this is butane, butane is an alkane. What do I know? What do we know about alkanes? We know that alkanes is a hydrocarbon. And what do we know about these alkanes? We know that they are saturated. When I say a hydrocarbon is saturated, it means that you have to experience a single covalent bond between the carbon-carbon bond and a single covalent bond between the carbon-hydrogen bond. So alkane is a hydrocarbon. What is a hydrocarbon? A hydrocarbon is a compound made basically of what? Carbon and hydrogen. That's a hydrocarbon. And alkane is the simplest and even the most useful of all the hydrocarbons. Why? Because these alkanes have, in terms of molecule size, they are small. And the smaller the molecule size, the better. Because there are actually some properties that are dependent on the molecule size of a hydrocarbon. So the molecule size of a hydrocarbon will affect the boiling point of that hydrocarbon. It will affect the flammability of that hydrocarbon. It will affect the volatility of that hydrocarbon and viscosity. Okay, I'm talking about this question, but don't worry, our intention is to answer this question. But like I said, we're going to use one stone to kill so many of the birds. By the time we answer this question, you would have actually refreshed your mind on hydrocarbons and I'll take us back to quantitative chemistry. For those of us here in Nigeria, quantitative analysis. All right, so for this, the molecule size will affect some properties. It will affect boiling point. It will affect flammability. It will affect volatility and viscosity. You see alkanes. I'm talking about alkanes because of butane. This alkane, the molecule size is small molecule size. So because of this small molecule size for the alkanes, the boiling point will be low. Boiling point low. Flammability high. Volatility high. Viscosity low. I'm talking to the 11th graders. You know, you must have heard, you must have done this in class. But let's add meaning. Let me just add meaning to the understanding you have. That's what this video is for. So this butane from this question, we already know that this is what we have in the cylinder. So because it is butane, you should just know that before you answer this question, that this thing is an alkane. And if it is an alkane ending with the ANE, then you should know that this alkane is a saturated hydrocarbon. What do I mean by saturated hydrocarbon? For a saturated hydrocarbon, you have a single covalent bond. This dash you're seeing here represents the covalent bond. This is the stick method of representing molecules. So this is the carbon-carbon bond, single bond, the carbon-hydrogen bond, single bond for an alkane. It is important for you to know that alkane is not a functional group. It's not at all. It's not a functional group. All right. So the molecule size of alkane affords alkane these properties: low boiling point, high flammability, high volatility, low viscosity. What do I mean by viscosity? Let me start with viscosity. When a liquid is said to be viscous, it means it is thick. Think about your palm oil that you have kept somewhere in a very cold day for a while. Think about honey. Think about ketchup. Think about jam. These are examples of viscous liquid. The viscosity, when we say the viscosity of a liquid is low, it means it is not thick. Good. So the viscosity of alkanes is low because of the molecule size is small. 1. Volatility is another property. The volatility of alkanes, they are really high. And what do I mean by volatility? The ease at which a substance turns to gas. So when I say this liquid is very volatile, what I mean is just like this, from liquid to gas. Their flammability, of course, the ability for it to burn without smoke. Clear flame, not smoky, is very flammable. Then, of course, boiling point. And this boiling point, so these properties of alkane makes it a very useful fuel. Alkanes are better fuels than even the alkenes and the alkynes. Okay, it's important that we just take note of it. But that's not where we're going to right now, because our focus is to stay around this. But like I said, I'll not jump into answering these questions. I will even solve this in maybe my next video. But I want to clear the way for us so that we have an idea of what we are talking about. Because when most of us leave questions like this blank, it's because we don't even know where to start. And now I'm trying to help us to know that because they are talking about butane, know that it is an alkane. And if butane is an alkane, then this is what you should expect. Single carbon-carbon bond, single hydrogen, single carbon hydrogen bond for these alkanes, and that alkane is not a functional group. I'll bring us with different functional groups when I will do different part series for chemistry of the functional groups. I'll break it in bits. Good. Now, for molecule size, I said that the molecule size of these hydrocarbons determine these properties: boiling point, flammability, volatility, and viscosity. And that for the alkanes, boiling point is low, flammability high, volatility high, viscosity low. Next, the next thing I'd like us to know about this is that if this is butane, then you should be wondering, what does this mean? The prefix here, but, tells you that there are 4 carbon atoms. But if it is pro, 3 carbon atoms. If it is et, 2 carbon. If it is met, 1 carbon atom. So that when you see methane, you know that because it is met, 1 carbon atom. Then et, ethane, 2 carbon atom. Propane, 3 carbon atom. Butane, 4 carbon atoms. We can go on and on. If it is 5 carbon atoms, then you will see something like pent, 5, hex, 6, hept, 7, oct, 8, non, 9, dec, 10. So that when you hear pentane, hexane, heptane, octane, nonane, decane, just know that. So once you know this prefix, you are fine. Then but, you add ene, butane. Pro, you add but, ane, butane. Ane, propane. Et, ane, ethane. Met plus your ane, methane. And you go on and on and on. For these hydrocarbons that we call the alkane, if you know that the number of carbon atom is 4, the number of carbon atom is 5, the number of carbon atom is 10, then how will you determine the number of hydrogen atom that should accompany it? We use a general formula for this, and the general formula is CnH2n plus 2. You see, this is the general formula we use for alkanes, where N is the number of carbon atoms. So how do we know that hydrogen here for butane is 10? Simple. If we are looking at but, and we know that but is 4 carbon atoms, N here, number of atoms, so that anywhere I see N for butane, I'll put 4. So that this will be 4 here, C4. Then N here representing the number of atoms. So that anywhere I see N, I put 4. This is going to be 4. So that 2 times 4, 8. 8 plus 2, 10. This is the general formula for representing this alkane. So what do I want us to know? For now, I want us to know that before we talk about write a balanced symbol equation for the complete combustion of butane, this one, they are talking about one of the reactions that this hydrocarbon undergo, which is complete combustion. You will need to know what are the products of a complete combustion of butane. And apart from butane undergoing what we call complete combustion, we also have the incomplete combustion. So if a hydrocarbon undergoes a complete combustion, what will be the product? And how will you test for the product? If a hydrocarbon undergoes an incomplete combustion, what will be the product, and how will you know? So this is what I want us to know. When I come back for the next part of the video, I'll start by discussing combustion of these hydrocarbons, complete combustion and incomplete combustion. I'll talk about the product of a complete combustion, the product of an incomplete combustion, test for this product before I start answering this question. Like I said, the way my videos work, I like to use one stone to kill so many birds. So before I answer that question, if you are a very smart student, I would have answered 10 or even 15 of other questions that you will see related to that topic or adjacent to the topic. Until I meet you again, continue to study. Bye for now.